Our general quadratic function can be obtained by stretching and shifting the y equals x squared function. We get the general quadratic function y equals ax squared plus bx plus c. The stretches and shifts we're talking about are vertical stretches, and the vertical stretch that we use is going to be the number in front of x squared, and that is incidentally going to determine when we move one unit to the right or left of the vertex, how far up or down we move. We'll move a units up, and if a is negative, then that's actually downward movement. The b and c in this form don't correspond precisely to any shifts, but we're going to say that we can vertically stretch the function, and then we can shift it horizontally and vertically, or vertically. Okay? If we stretch it vertically, then we add a number that we're going to call k. And that, of course, has the effect of raising the vertex to y-coordinate k. And then we shift. Now, horizontal shift, it turns out, is obtained by subtracting whatever distance we want to shift it, or through whatever displacement we want to shift it from x in the expression here. So we have this standard form, which has the vertical stretch, the vertical shift, and the horizontal shift represented by the three parameters. In any case, we have three transformations, three geometric transformations, one stretch and two shifts, that will change the shape to any narrowness or fatness we want to have for the parabola, and then a vertical and a horizontal shift that will take the vertex wherever we want it to be. We use three parameters to accomplish that, one parameter for each shift. And even when we express it in different form, we're still going to have three arbitrary parameters for a quadratic function. If we stretch and shift the function y equals 2 to the x, we get the exponential function, which has basic form y equals ab to the x plus c, or y equals a times 2 to the kx plus c, depending on which form is more convenient for the application that you're considering. Each of these forms has three parameters corresponding to the three geometric transformations. It's going to turn out that with exponential functions we use a vertical stretch, and that's going to be a. We use a vertical shift, and that's going to be c. And we use a horizontal horizontal stretch. The horizontal stretch turns out to be 1 over k. It doesn't have any direct relation to b. So that if we look at k here, we stretch horizontally by factor k. Another way we can think about by factor 1 over k. Another way we can think about that is to compress the graph by a factor of k. But we'll talk about that later on. That's just a preview of some of the terminology. The thing we want to emphasize here is that we take these functions and we apply geometric transformations to the functions, and we represent those geometric transformations, those shifts and stretches, by algebraic functions.